So in continuation with the previous topic, now we'll see the effect of change in g of s into h of s on steady state error. That is type of a system. So let us consider open loop control system. O dot L dot C dot S means open loop control system. So open loop control system will be denoted by g of s into h of s. So we know that the closed loop control system will be represented by g of s divided by 1 plus g of s into h of s. Okay. So that is the difference between open loop control system and closed loop control system. Is generally represented by k into 1 plus t1s into 1 plus t2s plus dash dash divided by s to the power of j in the bracket 1 plus t subscript as into 1 plus tbs dash dash. Okay, wherein k stands for the gain of the system and j stands for the type of the system. Remember, if j is equals to 0, then it is type 0 system. If j is equals to 1, then it is type 1 system. If j is equals to 2, then it is type 2. If j is equals to n, then it is type n system. So now we'll see the analysis of type 0, type 1 and type 2 systems. Now we'll see the analysis of type 0, type 1 and type 2 system. So let us consider first type 0. For type 0, j is equals to 0. That means s to the power of 0 is equals to how much? 1. So if we substitute j is equals to 0 here in this equation, in open loop control system, g of s into h of s can be written as k into 1 plus t1s into 1 plus t2s divided by s to the power of 0 is 1. So here it will be 1. Okay, if you write or if you don't write, no problem. 1 plus tas into 1 plus tbs. Okay, for step input already we have derived an expression for positional error coefficient, that is kp is equals to limit s tends to 0 g of s into h of s. Okay, kp is equals to limit s tends to 0 g of s into h of s. We are calculating it for step input, remember. Okay, so if you substitute g of s into h of s here, so there is no, okay, so if you substitute g of s into the h of s, this here, so s will be 0, this s will be 0, 0 into this will be 0, okay, 0 into this will be 0, so it will be 1, it will be 1, and numerator will get constant, in the denominator also you will get a constant. Constant by constant you will get a constant itself. Okay, constant by constant you will get a constant itself. So, and already have calculated ESS for step input is a divided by 1 plus kp from previous topic. You just go through the previous topic. ESS is equals to, for step input, a divided by 1 plus kp. Here kp is equals to how much? You got k. ESS is equals to how much? A divided by 1 plus k. So same thing will represent, that is step input will be represented normally like this. Okay, so this one the actual output, desired output, and this is the actual output. Remember, actual output may be exponential or actual output may be oscillatory. So here I have considered both, just to show you people. I am taking both exponential as well as oscillatory. Okay, so the desired output will be this. I have considered my actual output as exponential. So the difference between desired and actual will be ESS. So from this, now what we got, ESS is equals to 1 divided by a divided by 1 plus k. So here this gap between these two is represented by ESS, that is equal to a divided by 1 plus k. Okay, so here the same, instead of considering exponential, I have considered oscillatory output. So this gap I have represented ESS, that is difference between desired and actual. ESS is equals to a divided by 1 plus k. Okay, second one, type 1 system. For type 1 system, j is equals to 1 and s to the power of 1 is equals to s. So g of s into h of s, again open loop control system. From the main equation we can write k into 1 plus t1s 1 plus t2s divided by s into 1 plus tas into tbs, because here s to the power of j, sorry, j is here, j is equals to 1, s to the power of j is equals to s, so I have taken s here. Okay, yes, I have taken here. So then kp is equals to, again from positional constant error. Okay, kp is equals to limit s tends to 0 g of s into h of s. Okay, so that kp I have substituted this value here. After substitution again, okay, limit s tends to 0. So the numerator s into this, right, s, limit s tends to 0. 0 into this will be 0. 0 plus 1 is 1. And here also 0 into this is 0. 0 plus 1 is 1. So in the numerator will get constant, but here in the denominator will get 0. Okay, so numerator you will get, numerator here you will get constant. Okay, numerator will be constant and denominator will be 0. Anything divided by 0 will always tends to infinity. Okay, and we have the expression ESS is equals to again a divided by 1 plus kp, right? A is equals to 1 divided by 1 plus this infinity, kp value is substituted infinity. So infinity plus 1 is again infinity, right? Anything divided by infinity is always 0. That means error we got here is 0. So this 0 error I will express graphically as step input I will consider. Okay, step input I will consider, and the actual output I have considered here is exponential. As I got 0 value, I am touching this actual output to this desired value. So there is no gap I am keeping here, right? That's why ESS is equals to 0. This is exponential output I have considered. If you want to consider oscillatory output, you can also consider oscillatory output. This is the actual desired, so this is the desired output. You can consider actual output as oscillatory, and at the end you should touch with this line so that you can show ESS is equals to again 0. Understood? So similarly you can go for type 2 system. For type 2 system, j is equals to 2, s to the power of j is again s square. Again g of s into h of s is equals to, you substitute the value of this in the standard previous equation, you will get this k into 1, k in the bracket 1 plus t1s into 1 plus t2s divided by s square, this, right? And you already know the value of kp. Kp is equal to limit s tends to 0, g of s into h of s. You substitute this here. Okay, again in the numerator s tends to 0 means this will be 0. 0 plus 1 is 1. Again this is 1. 1 into 1 again constant will get here, and numerator will get 0. Anything divided by 0 is infinity. Again you know the value of ESS is equals to a divided by 1 plus kp. A divided by 1 plus infinity. Infinity plus 1 is again infinity. Anything divided by infinity is always 0. Again the ESS for type 2 system with positional constant kp is again 0. That's why again I am showing graphically like this as like previous. Okay, so for step input we have considered type 1, type 0, type 1, type 2 system, right? So similarly the next 2 iterations will be, one is for ramp input, one is for parabolic input. Okay, just to go through the nodes you will come to know, please.